Good morning to all. We have already gone through association rules and all. Now here in this slide, we will discuss what are the different types of data which we have to take or consider as transactions, and also we will go through the introductory part of sequential algorithm. So here first topic is data formats for association rule mining. There are different data formats which could be taken as converted as transactions and could be used for association rule mining. The first one is text document. In text document, what we do is we convert each document as transaction. We consider each document as transactions and each word as an item. So distinctive words are taken as item, and if you have any duplicate words, you remove them. You take only a single copy of each word. Next is relational tables, where you convert a table data set to a transaction data set. You have different tuples, so each tuples will be considered as different transactions, and the values of the tuples will be taken as attribute value pair. For example, you look at the example here. We have a relational table where we have the values attribute 1, 2, 3, and the values are a, x, b, and y. Here what we do is I have converted the whole relational table to two transactions, transaction 1 and transaction 2. In transaction 1 I have attribute 1 comma a, attribute 2 comma a, attribute 3 comma x. So this is my first transaction, and each value is an attribute value pair. Now if I have numerical values, what I would do is I would convert the value into categorical values. What I would do is I would divide the whole set of values into different groups, categories, and I would assign each value to the corresponding categories. So that is how I convert the numerical value to transactions. So I have different transactions as different categories. Now this categorization, either for example here, if I have a value range from 1 to 100, I would divide into 5 equal sized intervals, and I would assign the values to different intervals to which it belongs. Or I can convert it into binary representation. That is, if a value belongs to a particular category, it is represented by 1, and if it doesn't belong, it is represented by 0. So these are the different methods of representing different types of data as transactions. So hope you understood. Now next is the basic concepts of sequential patterns. In sequential patterns, till now we were developing association rules for different data, and we were not considering the order of transactions. We were okay with whatever be the order of the transaction. We get a data, and we don't give much importance for the sequence in which the data appear in a transaction, or the sequence in which the transactions appeared, the order in which the transactions appear. So they were not given much importance. So here there are certain areas where this sequence also have their own importance in finding the association rules, for finding the rules. So here what we do is we are using here in this particular concept, what we do is we are finding out the sequential patterns, not simply association rules, but we are finding the sequential patterns for the market basket analysis, web usage mining and text mining, everything where the order is also having importance. So that is sequential patterns. So sequential patterns are the method of finding different rules where we give importance to the order of transactions. Now these are the basic concepts of sequential patterns. Capital I, as always, stands for the set of items. S is the sequence, that is we have different sequence ordered list of item sets. So when we go through the example, it will be more clear. And capital X is the set of item set in each sequence. Now sequence S is always denoted using A1, A2, A3 up to AR, which are termed as the elements or item sets in X. So this A1, A2, A3 are the elements, and each A1 has a set of values, a set of items from item set. That is, A1 will be having S1, S2, S3 or something, a group of items. A2 will again have X1, S2, S3 or some group of items. In that way, we will have each elements which have a certain set of items, and A1 is a element, A2 is another element, A3 is another element in S. Now, let me show you the example. Just go through this example and we will go through the previous slide. That will give you more clear idea. Let I be an item set where we have around 1 to 9 items. In this, S1 is a set of elements, is a sequence. S1 is a sequence, and we have the value 3, 4, 5, 8. Now, 3 is one element, 4, 5 is the second element of S1, and 8 is the third element of S1. In the same way, S2 is another set of elements, that is 6 first element, 3, 7 second element, 9 third element, 4, 5, 8 fourth element, and 3, 8 fifth element. It means that S1 has a set of transactions, a set of 3 transactions which are being done by the same customer. If it is in the case of customer's preference, it is the 3 transactions done by the same customer 3 different days. S2 is the set of transactions which are being done by a particular customer at 5 different days. So that's how we create different sequence. If it is based on customer relation, customer's ID or customer preference. If it is some other case, we would be having some other sequences based on some other categories. Here we are taking, for example, customers or transactions in a supermarket. So that's why I explained in that way. So here S1 have 3 elements, S2 have 5 elements, and this 3 is termed as the size of the sequence. If that is the case, S1, the size of the S1 is 3 and the size of S2 is 4. No, sorry, 5. S2 have 5 elements, right? So the size is 5. 6, 3, 7, 9, 4, 5, 8, 3, 8. So 5 elements are there in S2. So the size of the S2 sequence is 5. Now let us consider what is length. Length means how many number of elements are there in a particular sequence that contributes to the length of the sequence. So if S1 have, here in S1 have, we have 4 elements, 3, 4, 5 and 8. So the size of S1 is 4. In S2 we have 6, 3, 7, 9, 4, 5, 8, 3, 8. So we have 9 elements altogether. So the length of the sequence, second sequence is 9. Now we have to note one thing. If 3, for example in S2 the second element 3, 7, we have the value 3, and the fifth element we have the value in 3, 8 we again have the value 3. If this 3 appears in 2 different elements for the same sequence, they are also considered when we consider the length of the sequence. When we count the values for finding the length of the sequence, both the 3's would be considered. But if I have 3, 7 and again one more 3 in the second element, I would take only one 3. That is, an item can appear more than one times in different elements in a particular sequence, but an item in an element should appear only once. That has been explained here. Now the second concept, that is supersequence and subsequence concept. Here in this particular example we have 2 sequences, S1 and S2. I can say S1 is a subsequence of S2 such that if each element of S1 is a subset of other elements in S2, then only it could be considered as a what? As a subsequent, and also in the increasing order. That is, here 3 is the subsequence of 3, 7, subset of 3, 7. 4, 5 is the subset of 4, 5, 8, and 8 is the subset of next element, that is 3, 8. Then only we will consider as S1 as the subsequence of S2, or S2 is the supersequence of S1. So they should be the subset and in the increasing order. 4, 5 should not appear at this location. After 3 is considered as the subset of 3, 7, 4, 5 should be the subset of some other elements in this direction. So that's how we'd explain subsequence and sequence, and that is what is explained here. We have two sequences, S1 and S2. S1 have A1, A2, AR, S2 has B1, B2 up to BV. In that case, S1 is subsequence of S2 or S2 is supersequence of S1 if 1 less than equal to J, 1 less than equal to J2 up to less than equal to V, such that A1 is a subset of BJ1, A2 is a subset of BJ2, that is, it has to go to the second value. Likewise, it would continue. Okay, so hope you are clear with every concept. We will go with the examples next class. Thank you.